I'm Bella. Welcome to my YouTube channel. In this video, I will share with you Form 4 Chapter 1 Functions. Basically, function is a relationship between one number which we call it as an object and another number which we name it as image. But we just represent this relationship by using an equation. So, without further ado, let's start! KSSM Syllabus Form 4 Chapter 1 Function. Function can be presented in three different ways, such as graphical, arrow diagram, and function notation. It is just like a person wearing different color t-shirt. Okay, just like this is wearing red color, this is wearing blue color, this is wearing black color or yellow color. Okay, so let me show you. Okay, let's say this is 1 and this max to 2. And you see here, you see the arrow diagram. The 1 is mapping to 2. And let us see the function notation. Let me substitute x equals to 1 inside the notation. Okay, it becomes 2 times 1, it becomes 2. Do you see that? It's still 1 max to 2. So they are the same thing, just they look not the same. Okay, there's still another one which is named as ordered pay. Ordered pay. How can the ordered pay be written? Okay, it will really look like 1, 2. You just use all the point in the graphical, just put inside. Okay, 1, 2, 2, 4, 3, 6. Then this is the answer for ordered pay. So when the question come out is in an arrow diagram, if you are very familiar with arrow diagram, then you can answer it right. If it is out in the graphical form, if you feel like not really familiar with it, actually you can change it directly to the arrow diagram, then you will feel familiar to answer it. Okay, let's go to the next page. Now I want to introduce you what is domain, codomain, range, function notation, image, and object. These four things. Now I want to introduce you what is domain, codomain, range, function notation, image, and object. Okay, let me show you. Domain is all the number in this circle. That's called domain. Okay, let me. 1, 2, 3. This is the answer for your domain. Codomain is all the numbers in the second circle. Okay, which is 2, 4, 6. How about the range? Range is all the numbers that got relation with the domain. Okay, so it will be 2, 4, 6. Let me give you an extra example. For, let's say, 1, 2, 3, 2, 4, 6, 8. Okay, what is the domain? 1, 2, 3. Okay, still the same. 1, 2, 3. How about the codomain? Codomain is all the number in this circle. All the number. So it will be 2, 4, 6, 8. Okay, how about the range? Range is the number that got relation to the object or the domain. So it's only 2, 4, and 6. Okay, it doesn't include the 8. Okay, 2, 4, 6. So you must know how to differentiate the codomain and range. Now we go to the function notation. Okay, for function notation, you have to see the relationship between the object and image. You see, 1 become 2, 2 become 4, 3 become 6. What do you think? What is the relationship? Times 2. So the function notation will be fx equals to 2x. This will be the function notation, which is look like this. Okay, in either way you may write it like this. Okay, okay. Image of 2. Okay, here the number here is the object. The number here is the image. So it will ask you the image of 2. What is the image of 2? The image of 2 is 4. What is the object of 6? This is the, all the number at here is the image. All the number at here is object. So it's the question asks you, what is the object of 6? Is 3. Okay? Now, let us learn about relation of a function. Okay, the first relation is 1-to-1. What is meant by 1-to-1? One object related to one image. That's called 1-to-1. One to many. One to many. Okay, one object got relation with many image. Okay, many to one. That means many to 1. It will be look like this. They have got 2 objects with the same image. The 2 objects got the same image. Okay. Many to 1. They have got 2 relationships inside here. 1 to many and many to 1. That's what we call many to many. Okay. For your information, only 1 to 1 and many to 1 is function. This is not a function. This is not a function, okay? And we got another test that can test whether it is a function, which is vertical line test. Let me show you an example. Let's say this is a linear graph. What it means by the vertical line test, it will be vertical line cut through the graph. If it is only cut through one point, then this is a function. Let me give you another example. This is a quadratic graph. So the vertical line test still cut through one point. So this graph is a function. Let me give you the last example. Let's say like this. The vertical line cut through 2 points. So this is a function? No, this is not a function. Let us go to the example 1. Given that f(x) equals to 4/1 minus x, find the value of x such that the function f is undefined. So let us understand what is mean by undefined. Okay, let me show you. 4/0. If you press your calculator, what will be the answer? Max error. That's mean by undefined. When your denominator is equals to 0, your answer, the function will be undefined. So now let us get back to the question. f(x) is equals to 4/1 minus x. What is the condition when this function will be undefined? When the denominator is equals to 0. That means 1 minus x is equals to 0. The function f will be undefined. Okay, so when x is equals to 1, the function f will be undefined. Okay, so let me give you one more extra example. f(x) equals to 1/x. What do you think will be the answer for the function f to become undefined? The x is equals to 0. The function f will be undefined. So every time when you see your question, you will see that the question beside the function, it will have something like this. The x cannot be 0. Why the x cannot be 0? When x equals 0, it will be undefined. That's the reason. Example 2. This is a long question. I hope you can pay attention, okay? The diagram shows the graph of function f(x) equals to 1 minus 4x. Find f negative 1. Okay, before I go to find the answer, let me introduce what is this. This is modulus. Okay, modulus means every number inside here will become positive. Let's say negative 1, it will become positive 1. Negative 2 inside the modulus, it will become 2. if positive number is still positive, okay? All the number will become positive, okay? Let us proceed to A. F negative 1. So we substitute x equals to negative 1 into the function, okay? Function 1 minus 4 negative 1. You see that? I put my x is equals to negative 1. Here I substitute my x is equals to negative 1. So I will get my answer as 5. So my final answer is still 5. Okay, let us go to B. The values of x such that fx is equals to 11. Do you notice that the values? Okay, so that means at least 2. Okay, fx is equals to 11. What will be the answer of x? Like, okay, what you mean by this is a function notation. Let us go to the first page. Okay, the function notation means this is the image. Do you see? This is the image. Here is the object. So when the image is 11, we want to find the x. Let us go back to this graph. So the image is 11. So we have to go and find the object. Here is the object. Here is the object. Okay, so with fx is equals to 11 modulus here 1 minus 4x is equals to 11. Since this is modulus, so we become 1 minus 4x equals to 11. 1 minus 4x is equals to negative 11. Because when it is negative 11, we put inside the modulus, it will still become 11, which is the same here. If inside is negative 2, it's still 2. If inside is positive 2, it's still, the answer is still 2. That's why we got 2 possible answer, okay? So 4x is equals to 1 minus 11. 4x is equals to negative 10. X is equals to negative 5 over 2. Negative 4x is equals to negative 11 minus 1. Negative 4x is equals to negative 12. X is equals to negative 12 over negative 4. The final answer for x is equals to 3. So there got 2 possible answer for the x, okay? Which when x is equals to 3, my fx will be positive 11. When my x is equals to negative 5 over 2, my fx will also become 11. Let us do some proving, okay? Let me see. F3 is equals to 1 minus 4, 3. Okay? 1 minus 12 modulus. 1 minus 12 become negative 11. So since this is negative 11 inside the modulus, it still will be 11. So do you see that when the object is 3, the image will be 11. So this one left it to you to prove, okay? Now we go to see the C. The value of x which max to itself. Let us learn what is max to itself, okay? Max to itself means the object and image is the same. Okay, let me show you. Okay, max to itself, if we draw it in an arrow diagram, the x become x. The object and the image is the same. Okay, so let us find the value of x. That means the object and the image is the same. The image is 1 minus 4x modulus is equals to x. 1 minus 4x equals to negative x. 1 minus 4x is equals to positive x. Same as the way we do it here, okay? Okay, so 1 is equals to negative x plus 4x. So 3x is equals to 1. X is equals to 1 over 3. 1 minus 4x is equals to x. 5x is equals to 1. X is equals to 1 over 5. So there we got 2 answers for the x. Okay, let me prove you what is meant by the object and image is the same. Okay, let me choose this. Okay, when fx is 1 over 3. The x is 1 over 3. Okay, the function 1 minus 1 over 3 modulus. Okay, 1 minus 4 over 3. What will be the answer for 1 minus 4 over 3? It will be negative 1 over 3. So the answer will be, since this is modulus, the answer will be 1 over 3. Do you see that? Do you see that? The object and the image is the same. That means maps to itself. The object and image is the same. Okay, this one I left it to you to prove it. Okay, let us go to the part D. The domain of fx is smaller than 5. What does it mean? Okay, let me show you. The graph is this. Okay, the fx is smaller than 5. Before we find the range, let us find what is the x value when fx is equals to 5. The same way we find in part B. Okay, so we have to find the value of x, the value of the 2x when the fx is equals to 5. Okay, the fx is equals to 5. Modulus 1 minus 4x is equals to 5. 1 minus 4x is equals to 5. 1 minus 4x is equals to negative 5. Because when 5 is inside the modulus, it's still 5. If negative 5 inside the modulus, it's still 5. Okay? 4x is equals to 1 minus 5. 4x is equals to negative 4. X is equals to negative 1. So I know my answer here is negative 1. Now, 4x is equals to 1 plus 5. X is equals to 6 over 4. X is equals to 3 over 2. So another value is 3 over 2. So now, let us go back to the question. The question wants us to find fx is smaller than 5. What is the range for smaller than 5? Here is larger than 5, right? Here is smaller than 5. So it will be the range here. Here is all the value which is smaller than 5. So what will be the domain? The domain will be here. Okay? So the final answer is in between negative 1 x 3 over 2. This is the final answer. Okay, let me ask you, if in case my question changed to fx greater than 5, what will be my answer? Okay, fx greater than 5. So here is the part which is fx greater than 5, which is here and here. So what will be the answer for this question? It will be x smaller than negative 1, or the x is greater than 3 over 2. Okay, so this will be the answer if the question is fx greater than 5. Now we go to the part E. Part E wants us to find the domain of fx which is larger than 11. Here at the part B, we already find the value of x when the fx is equals to 11, which is negative 5 over 2 and 3. So now we have to find the part which is the fx is greater than 11, which is here, greater than 11. So it will be here and here. So what will be your answer? My answer for part E. Okay, my answer for my part E will be x smaller than negative 5 over 2, or my x is greater than 3. This is my final answer. Let's say if I change my question become fx smaller than 11, what will be my answer? Fx smaller than 11. What do you think will be my answer? Fx smaller than 11 will be in this range. So it will be in negative 5 over 2, x 3. This will be the answer. Okay? Let us go to example 3. Given gx is equals to px squared minus qx, where P and Q are constants. If G3 is equals to 12 and G4 is equals to 28, find the values of P and Q. I want to tell you this question is a popular question. Okay, so you must know how to solve this question. Okay, G3 is equals to 12. This is, what is this? You must know. This is object. This is image. Okay, G3 is equals to 12. X is equals to 3. When X is equals to 3, your P, I substitute 3 inside here. Okay, do you see that? I substitute 3 inside here. So 3 square minus Q3. It will be 9P minus 3Q. So from here, we know that it is equals to 12. So I can simplify it, become 4 equals to 3P minus Q. So I can modify it, become Q is equals to 3P minus 4. This is my first equation. Okay, let us go to the second one. Now, my object is equals to 4 and my image is equals to 28. So, I will substitute X equals to 4 into here. X is equals to 4, X is equals to 4, and 4 into here. Okay, so X is equals to 4 is equals to P 4 square minus Q 4 at here. Okay, so 16P minus 4Q is equals to 28. Now I will simplify it, become 7 4P minus Q. And another one, I make it become Q is equals to 4P minus 7. This is my second equation. Now, I can equalize my first and second equation. Equalize my first and second equation, become 3P minus 4 is equals to 4P minus 7. 4P minus 3P minus 4, here move to here, become positive 7. So, P is equals to 3. After I get my P is equals to 3, I can substitute into either equation 1 or equation 2 to get my Q. So, I can get my Q is equals to 5. Okay, now let us go to the composite function. Example 4. Given that fx is equals to 7x plus 2 and gx is equals to 5 minus 3x, find gfx. So, just now we know that fx is equals to 3x plus 2. We say that this one is the object and this one is the image, right? Okay, now what is the meaning of composite function? It becomes like this. Fx is your object. Okay, so you will substitute your fx into here. Fx is 7x plus 2. Okay, so this is become your object. Just now, when we say that if we substitute 3 at here, then we will substitute 3 at here, right? We will substitute to the same place. This is now your object. So, where is your gx? Gx is 5 minus 3x. So, I will substitute my object into here. Okay, I will substitute my object into here. So, it will become 5 minus 3, 7x plus 2. So, I will substitute the object into here. Okay, the fx become my object. Okay, so 5 minus 21x minus 6. So, it will become minus 21x minus 1. Now, let's just go to part B. Fgx. So, now the gx is the object. Fgx. So, this is the object. Let us put the object inside. Gx is 5 minus 3x. Now, this one is our object. I want to put it into my function f. So, this one is my object. Do you see that? F, this is the object. F, this is the object. Now, I want to put inside here, okay? 7x plus 2. So 7, 5 minus 3x plus 2. It will become 35 minus 21x plus 2. The final answer is this. Okay? Okay. F square x. What does it mean? Not square. It's not square. It look like this. Double function f. Okay? Double function f. So this the same way. This is the object. So the function f is 7x plus 2. Now I want to put the 7x plus 2 into the x here. So still the same, 7x plus 2 plus 2. Do you see that? This is the object. I want to put into the function fx plus 2. Okay, 7x plus 2. So it becomes 49x plus 16. Okay. Now let us go to the example 5. Given the function fx is equals to x plus 3 and gs is equals to ps plus 2, find the value of p if fg2 is equals to 11. So this is a composite function. fg2 is equals to fg2. Okay, now let us go and find what is g2. Okay, g2 from here, the function gx is equals to px plus 2. If g2, my x become 2. So p2 here plus 2. So it is 2p plus 2. So actually this one is 2p plus 2. So now I want to substitute my object 2p plus 2 into my function fx. So 2p plus 2 inside here plus 3. Do you see that? 2p plus 2. Okay? Just in case you can see it, 2p plus 2 inside here. Okay, become this. So if my answer will be 2p plus 5. So after I find my fg2, my answer is 2p plus 5. I will equalize to become 11. 2p plus 5 is 11. So 2p is equals to 6. P is equals to 3. Finally, I find my P. Okay, now we go to B. This is A. Okay, GF3 is equals to 3P. Don't worry about the 3P. Let us find the left hand side first. Okay, GF3 is equals to GF3. Now we have to go and find what is F3. Okay, F3. I substitute my x is 3. So 3 plus 3 is equals to 6. So my G6. What will be my answer? G6. G6 is equals to 6p plus 2. So my answer is 6p plus 2. Now I can equalize my 6p plus 2 that I find from my left hand side with the right hand side. 6p plus 2 is equals to 3p. 6p minus 3p is equals to negative 2. 3p is equals to negative 2. P is equals to negative 2 over 3. Okay? Now let us go to example 6 and 7. Example 6 and 7, they look alike, but actually they are not alike. Okay? Let me show you. Example 6, given that gx equals to x over 5 plus 1 and fgx is equals to 2x plus 6, find fx. Just now, the question gives you the fx, gx, and it wants you to find the composite function gfx or either fgx. Now the question gives you the gx and fgx, the composite function, and it wants you to find the fx. Okay, so now I will show you step by step. Okay, the first step, I will see the composite function that the question gives me. What is the inside here? Okay, this is gx. Then the first step I will do is let gx is equals to m. The one I choose sure is inside here, not the outside one. Sure is the inside here one, okay? Gx is equals to 1. The second step I will do is I will put inside here and inside here. Okay, these two. So Gx is equals to m. So this is Gx. So this is equals to m. This one you want to choose P, Q, Z, O also can. Okay, anything you like. Okay, m is equals to x over 5 plus 1. X over 5 is equals to m minus 1. X is equals to 5 times m minus 1. X is equals to 5m minus 5. Okay, you have finished the first step. Okay, the second one, you have to put inside here. Gx is equals to m. So this is Gx. So this is m. Okay, so what will it become? It will become fm equals to 2x plus 6. Here, you have find that x is equals to 5m minus 5. You will put inside here 2 5m minus 5 plus 6. 10m minus 10 plus 6. 10m minus 4. You have found your answer. Why I say like this? You want to find your fx. Okay, here is your fm. You can just directly change it to x. Fx is equals to 10x minus 4. Okay, done. Now example 7. It is also look something like it is given that fx give you fgx, the composite function. Want you find gx. Seems look alike, but actually they are not alike. You see? For example 6, the question want you to find the function which is left hand side. The gx here is the right hand side. So actually it's not the same. Okay, so you have to be alert which one you want to find. Okay, now the first step here still the same. I want to go and see which one is the inside one. Oh, still the gx. So still the same. Gx is equals to m. So now I want to put it inside here. Put it inside here. Okay, you see it's the same. But you see gx, fx can be substitute here? Cannot. They cannot. We only can substitute the gx equals to m to here. So gx is equals to m. We will substitute into here. So it will become m is equals to 6x plus 7. Then how can we continue? You see, fm. Here become m. Here become m. So it will become 3m plus 4 is equals to 6x plus 7. Now we want to find my m. 3m is equals to 6x plus 3. M is equals to 2x plus 1. Okay, so your question want you to find 3x. Gx is equals to m. M is equals to 2x plus 1. So what will be the answer for gx? Gx is equals to 2x plus 1. That's all. Okay? Now we go to the inverse function. Let me draw you the arrow diagram. It will be look like this. Let me give you an example. 1, 2. This is the function f. What will you write for the function notation? f1 is equals to 2. Object image. From here to here, 1 mapping to 2. 1 mapping to 2. Okay? Then what is mean by inverse? Okay, inverse will be look like this. Turn back. Okay, this is your f inverse. If we want to write the function notation for inverse, what will be it look like? F inverse. The object will be, because it's mapping from 2 to 1. 2 to 1. Do you see that? Mapping from 2 to 1. It is always the object to the image. Okay? Now let us go to the example 8. A function is defined as fx equals to 2 plus 3x. Determine the f inverse. Okay, I will start with let f inverse x is equals to y. So my fy is equals to x. Do you know why? Let me draw you, okay? Actually, for here, this is the arrow diagram. Here is the f inverse. So let me draw you the f inverse. Here is the f inverse, right? This is the object for the inverse function. So this is the object. This is the image. That's why x to y. If we want to change to function f, then what will be the object? Y, x, isn't it? Okay, reasonable, right? Okay, fy, fy. So here is the y. So if I want to change it to become y, so it will be 2 plus 3y. 2 plus 3y is equals to x. 3y is equals to x minus 2. Y is equals to x minus 2 over 3. So my f inverse x will be x minus 2 over 3 because f inverse x is equals to y. Okay, let us find the f inverse with 2. So I just have to substitute the x equals to 2 into the equation. F inverse 2 is equals to 2 minus 2 over 3. It will be equals to 0. Okay? This is the last example for this chapter. Okay? The function f inverse is defined as f inverse a over x plus 3. Find fx. Just now, I give you the function f. And I want you to find the f inverse. Now, I give you the f inverse. I want you to find the function f. Can you? The way of finding is the same. Okay, let fx is equals to y. I will let the equation that I want to find is equals to y. You see here? I want to find f inverse, then I will let f inverse equals to y. I want to find fx. I will let fx is equals to y. So, you see? X, y. Okay, fx is equals to y. So, f inverse will be y x. Mapping from y to x. Okay, f inverse y. I will substitute here become y. Okay, it will be a over y plus 3 is equals to x. I want to find my y. A over y is equals to x minus 3. I want to find my y. Y is equals to a over x minus 3. So my fx is equals to a over x minus 3. With the condition, x cannot be 3. Why cannot be 3? Because when it is 3, the function f will be undefined. Okay? Let us go to find the part B. What is the value of a such that f2 is equals to 5? Okay, I will substitute f2 is equals to 5. A 2 minus 3. So a over negative 1. So it's negative a. Negative a is equals to 5. A is equals to negative 5. So this is my answer. Okay, that's all for this chapter. Hope you enjoy it. If you feel that it's helpful for you, do remember, please like, subscribe, and share the video. Bye!